this is lesson 15, and this covers sections 3.3 and 3.5, zeros and factors. We're going to find all zeros and factor completely. So to start with, let's take a look at some notes. Here we have a polynomial where a is coefficient, and we have x, and then to the n power, that would be your leading exponent. Such that we have x to the n, and then exponent, so n minus 1 and n minus 2 and so on. So if we had, let's say, x to the 7th power, then the next one would be x to the 6th, and the next to the 5th, and 4th, and all the way down to x, and then plus our constant. Where p is our constant for our last term, our a term. And q, that's our leading coefficient. And so we use that p and q to find our all possible zeros. We determine our p and our q from our last and our first coefficients. Determine all possible rational zeros by applying plus or minus p over q. We get factors for p and factors for q. Determine which factors are zeros. So we're going to set that equal to 0 and then use synthetic division. And if we have to, we'll use quadratic division or the quadratic equation as well. The fundamental theorem of algebra, where every polynomial, such as ax to the n, and so on, where n is going to be, of course, greater than or equal to 1, and our coefficient is not a 0, with all complex coefficients have at least one complex 0 in it. And all nth degree polynomials can have at most n real numbers. So we look at our exponent. And if our exponent, for example, is a 5, then that means we can have at most 5 real solutions, or 5 real zeros. So sometimes that might be a little useful for us to know that. Complex factorization theorem, where we have p of x is a polynomial with degree greater than n. In other words, it's going to be, it's not going to be at least a single number. Then there exist complex numbers where we have, and we can factor them out. We may have like a leading coefficient there, and then we have our factors, x minus c1, x minus c2, and so on. And we're going to use these factors to help us get our zeros. And if a factor, x minus c, appears k number of times, let's say we have an x minus 2, and then we have x minus 2 again, and that would be, we would have a 0. Our 0 would be 2 with a multiplicity of 2. We can say that there c is a 0 with a multiplicity of, in this case, k. Zeros theorem. Every polynomial with the degree greater than 1 has exactly n zeros, provided that the 0 multiplicity is k is counted k times. We're not going to use that one too much. The conjugate zeros. If a polynomial p has real coefficients, and we may end up with a complex solution, complex number, where we have real, which is our, in this case, x, plus I, so we get a complex number. Okay, so we're not going to use complex conjugates too much. Okay, so let's take a look at some problems. And we'll start with a nice and easy one, where we have x cubed minus 7x squared plus 14x minus 8. And sometimes it helps when we have four terms like this to see if maybe we can use factor by grouping, which in this case wouldn't help us any. So what we want to do is we want to find our p and our q. And so we have p over q is going to be factors of 8 over 1. So we use our p will go horizontally, q will go vertically. We need factors of 8, which will be 1 and 8, right? And we can also have 2 and 4, our factors of 8. Whereas factors of 1, well, that's just 1. And we go look at 1 down, 1 across. P is always the numerator, q is always in the denominator. So this will be plus or minus 1 over 1. Again, p is in the numerator, so this will be 2 over 1. Plus or minus 4 over 1, and plus or minus 8 over 1. So we can say that all possible zeros, emphasizing possible, is going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Okay, so we're going to use those to help us find our zeros. Okay, now next thing we do is we go to our calculator and we're going to enter that in. So we go to y equals, and we're going to enter in x cubed minus 7x squared plus 14x minus 8. And we're going to go to second and table, or table set rather, and you see where you have this chain, this triangle, or this delta table. You want to put that at 1, because it's easier to read. And what this means here is it's going to start our table of values at 0. And it'll do it in increments of 1. So let's go to second and table. And we said that we could have our possible zeros are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Well, we look at where will we have x values that has a y coordinate at 0. So 1 is a 0. Okay, so we're going to start with 1. And so this is what we've got. We've got p of x is equal to, again, I'm just rewriting this, x cubed minus 7x squared plus 14x minus 8. And we know that 1 is a 0. So we can say, since we know that